Hello, today I'm going to talk about my custom saving system for Unreal 5. To get started, I'm going to talk about my test project a little bit, as the details are kind of important for what the system is right now. First of all, it's a turn-based RPG. The fact that it's a turn-based is important because there's always like a specific situation when it's kind of safe to save and nothing is happening. There's no any kind of animation or enemy attacking or anything that might cause problem with saving in terms of like the status of an animation or some kind of latent function being triggered, not being able to save properly. Uh, Another thing, it's not a Lyra or gameplay ability system project. I have my own systems for stuff that like inventory and even abilities and actions. I have used both of these before in commercial projects, but not in my own project. It's not an open world or sandbox game. Each time you go to another area, there's like a actual loading screen and level transition. It's just a lot easier for me to do this way. It's not impossible to get this working for like a level streaming system, but you would have to do some considerations for like when you stream in a level, then you would need to handle that in kind of during the play while the player is still moving about. So I haven't done anything to test that kind of system yet. There's multiple characters, so in my project I have like a party system, and all of those characters can cross to the next level and come back, of course, too. And all of their items that they are wearing also cross with the player characters. The saving system is set up as its own plugin, so it's easy to get to work on another project. I will probably try to release the plugin soon. Okay. So what happens when the game saves? First, it finds all the global actors. So global actors is what I reference as the kind of actors that are always transitioning or always restore their state after you go to another level. So this includes player control, game state, player pawn. Could probably also add like game mode and stuff like that here. It's not like the actual actor object that's like transitioning, but rather when the new player controller and new game state spawns in the new level, then it like restores the values to that object in the new level, depending if they have the save game flag enabled. Uh, then there's also other global actors, so the player party. The game instance calls the player controller in my project, and the player controller has the player party component, and it informs the saving system like which actors are part of the party and need to be transitioned to the next level. Uh, then it finds all the local actors, so the local actors in the uh, that level and that have this interface, eSave interface, and then it checks from all the actors, including the player party and stuff like that, if they want to block saving. So this is important for situations like when there's an animation playing or there's some kind of script playing, script running that you cannot save during. Animation state is kind of tricky to try to save because usually animation blueprints are multi-threaded and I can have like a lot of complicated stuff going on. So I haven't tried saving animation states, and because when the animation is playing, I don't know, there might be like an animation events that can affect the gameplay. Like at certain point you receive damage. I don't want to save during animations. Um, so yeah, this is kind of handles that to make sure that you don't try to save when there's an animation. If I click save button, quick save button in the game, and it cannot save because one of the actors returns true with this function block saving, then I just set the boolean should save to true, and then the next frame, if any of the actors that have that enabled, then the game can save and the boolean can be set to false. So I have this whole can save function that I can check. Then next, if you are not transitioning to another level, there might be some actors that you want to kind of clean up. In my case, there's explosive barrels that can respawn when you go to another level and then come back. Also, same with a lot of breakable props like crates and stuff like that. This is just so that the level won't be completely empty once you have played the game for a little bit longer. This is just like a setting in my own props. It's not like a specific to the saving system, but just something you can enable if you want props to respawn after you come back. Check should save on actors. So, for example, those explosive barrels and breakable crates, once they have done the chaos physics animation and they are completely broken, I don't really try to save that state of them being broken. Instead, when you save the game at that point and load from the save, those props will have like completely disappeared. They won't save anymore. Same with characters. If the characters have ragdolled, I can save the ragdoll physics states, but if the character doesn't have anything in their inventory, then I don't need to save them at all, and I just skip them, and they won't reappear as a ragdoll into the level after you load the save. I also use an item pool, so when the game is kind of, you can kind of spam like throwing grenades or even like equipping and unequipping items, which like respawns the and destroys the item. But instead of destroying the item, I just put them into the pool, and when they are in the pool, they are invisible. They don't have collision enabled, and the player cannot interact with them in any way. And then when I need to respawn an item, I can check if there's any items in the pool and use them from the pool instead. But when they are in the pool, they don't need to be saved. So that's kind of optimization, that you don't end up with like a huge save file because there are so many items in the pool. Find tags for actors. This is important for actors that you have kind of pre-placed in the level by hand, and you want to reference in the code. This is more important for actors, like not physics objects or characters, but like manager actors that are kind of big actors that have a lot of data in them and are not meant to be like respawned into the system by the saving system, but rather are always there, and you don't delete them and recreate them. And for that, because Unreal is kind of weird about the object names, in the sense that even if you open the same level twice in a row, it can sometimes give the objects kind of a different name. Then because of that, this tag is kind of a unique name for the actor in the way that it will always find that actor with that name, and you can always reference to it, knowing that it's the specific actor that you want. Then it goes to the actual saving, so it saves all the global actors, meaning the player control, game state, player pawn, and the player party, and then saves the local actors, meaning the actors specific to that map with this interface. Then I actually save the data to a save game object using this function from gameplay statics. And that's the process of saving. The save interface, this is currently only on C++. I haven't used blueprint implementable or blueprint assemblable, like a blueprint interface here, because those functionals have kind of annoying limitations, and I want to deal with them. So the first function is the one I've already mentioned, block saving. Animation state cannot be saved easily. You can, of course, if you like, if you call play montage, you could like, of course, save the animation before that, and then after the montage is over, you can set the animation to null or whatever, and know that there's like animation going on. But then you also need to, if you wanted to um, save the animation state properly, you would also have to like save which frame in the animation you are, and maybe like even make sure that animation events don't trigger twice if you like save at a specific point. So it's just not something I have tried to like look into because I'm working on a turn-based game. Latent functions. So by latent functions, I mean stuff like I had an example here. Oh wait, I think I didn't maybe save that example. Yeah. So later function custom like do gameplay thing, and then you have delay, and then you do something big like some kind of gameplay effect. Um, gameplay effect. So you would like, for example, damage all the characters here. Um, uh, so you would trigger this function, this event somewhere, like maybe grenade explodes or something, and then you want to do the damage after one second. But if you save during this second, during this latent function, it cannot uh, properly save this function right now. You can, in some cases, save the latent data of like what to trigger after a specific moment, but it can be kind of tricky, and might not work in every situation. So you cannot like say while this is happening. So you, for example, here you should somehow have like some kind of boolean that sets, or some kind of function that disables saving and then enables the saving when this delay is over. I could go through like the latent manager and like go through everything that's stored there somehow, and try to restore that stuff too, but that might be like another problem for the whole thing, where it like causes other problems when some stuff that's not supposed to save would also like try to save because of the latent manager. Gameplay tasks. I don't really use gameplay tasks in my own project. mainly use latent functions because they're a lot easier to implement. You don't need to do like a whole class. Uh, um, I've used gameplay tasks, of course, in commercial projects, but not on my own projects. For the same reasons that you would somehow need to save the gameplay task object and then try to restore it if you are trying to save during that gameplay task. Should save, like I said before, for the breakable props and structures that have gone to a ragdoll and items that are in the pool, they return false, everything else returns true. Should respawn on level change, so this is for the breakable props that you do want to respawn after you have visited another level and then come back. Should delete on restore. So for the global actors and the map manager, this should be false, but for everything like physics object, like the items and then the player characters themselves and stuff like that, it should always be true because they need to be destroyed from the level and then recreated when the player like starts loads from the from the save file. Get saving tags so this is for the map manager. I think the global actors might also have this, but it's not really necessary because it kind of gives them a tag by default. And that's it. I do have a little bit more here in the C++ file. I have these two functions that I use to save the ragdoll and then clear the electoral state so that it will be saved. I have like attachment rules and uninstall function that gets called. This is to make sure that all the saving tags are unique, and something like that. But those are not as important. Per actor saving. So what happens in an actor when a specific actor is saved? First, it goes through all the properties that have the save game flag enabled. So you can look that this property float has the save game flag enabled here. It's might be hidden here until advanced, but then if you click, you can enable there. It's the same for like C++ classes. If I can find here some example. I don't know if I have a good example here with something that saves. Oh, here I should always show. So this property has the save game flag here. That means that it will always save. Then okay, go through all the components. So all the components of the actor can save through. There's some cases where they won't save, like skeletal meshes and visual components and audio components don't save by default, unless they have the force save tag enabled. This is just like an optimization because in some blueprints I had like a lot of skeletal meshes or a lot of static mesh components, and I felt lazy about going through all of them. So I added this thing where I don't really need to save all of them by default. I think there might be a bit of code where if a skeletal mesh has like an attachment, then it will force that to save, even if it has this force save tag. So if like an item is attached to a skeletal mesh, like in my case, there is this. If I run the utility and I look at this variable, so these are the classes. They are attached to this object with the index 39. And then if I look at the player structure in the save file and go down here, there's the skeletal mesh which has the index 39. So this item, these classes are attached to the skeletal mesh, and this skeletal mesh has been saved into the system here. I don't remember if it has force save enabled or if it's just because the system like automatically assumes that it needs to be saved because it has an attachment. For anything else, if the component doesn't have a don't save tag, so it kind of assumes that everything else except for these kind of things are like some kind of gameplay related object that needs to have its stuff saved. So in my case, like inventory component and what else do I have here? Like conditions component, action component, inventory components. That's customization, expressions, ability component, variable component, and stuff like that. Those all will be saved by default. Then I have the runtime pre-save, post-save functions that, like I said, allow the ragdoll be saved. So in this function, I save the ragdoll. Then a bit before this auto function is called, the data gets like put into the array, and then after that I can clear the array because it doesn't need to keep the data when it's just like normally running the game. It's just so that during the saving, that array of the ragdoll positions is occupied. The attachment parenthesis gets saved, so it knows what to attach the actor to after it has finished. Name and class are saved. The class is more important. The name is only used for the components. I don't try to restore the same object name after restoring. Unique object ID is saved, so that was the, for example, in this example 39. So because it's just like the index of this object in the array of all saved objects, so that means it's 39. Okay. A dynamic object is anything that is like created by some kind of component or actor. So here I have like these objectives that are referenced by the objective manager. So if I go here to objective manager and show data, I can see this array of objects, dynamic objects, and I can see them here. So all of these objects will be saved, and their data will be restored as well. Okay. On what happens when you are changing level? It's a little bit different when you are like saving the game normally. Pre-level change is called on game instance. So in my project, I have these things called voids. That is like rats, birds, uh, and even fish. And the game instance calls the player controller, and I think the player controller or the game state has the void manager, which then destroys all of the voids from the level. This is as an optimization when you change the level. So if you go to another level and then come back, it doesn't save the voids just because it wouldn't even make sense for all the rats or all the birds or all the fish to be in the same position, because usually spend some time in another level. If you save normally, they will of course stay in their their previous positions. But when you change level as optimization, it doesn't save them, and instead of like destroys all of them and makes the file size a little bit smaller. At this point, I also destroy all of the explosive barrels and stuff like that, even if they have not been destroyed, just to optimize the save file size a little bit more, and because they will be respawned by the system anyway. And then the global and local actors are saved into the save game object. Level change position tag is used to determine where you will like spawn when you go to the next level. So if you're using the front door, then it will use the front door tag. If you use the back door tag. I also have these boat, different boat routes, so you can take the boat to different locations, different maps. You can go to the store or the mansion or the boat hut, and depending which direction you are coming from, it will spawn you at a different position and spawn place the boat there as well. Level change tags are captured from the game instance. So I did have this example somewhere here. So these are just like what you will see in the loading screen. You can use this to like get a little bit of info during the loading screen of like who is going to another level. So here I'm just going through the party system and saving all the tags for the characters, and then returning those tags to like figure out who's going to another level. And I can show like their icon specifically in the loading screen. Then the loading screen is enabled and the new level is loaded. Okay, save game structure. There's the global actors. It's just like an array of actor save data. Current map name, levels. So each level has this struct for them, and then that struct has like a global not global actor, but actors array of actor save data in them. This custom object means like global custom objects. The level save data also has local custom objects array in it. So this means the objectives and also like player conditions and stuff like that. And save time. So this is important if you spend like 5 minutes in another level and then come back. This save time kind of keeps track of that how long have you spent in the world totally. Assets to load. So this is for kind of help with async loading. So before you start the restoring project, before you start respawning the actors, you can load all of the assets that you need to load asyncly and not have any hitches. Temporary data, this is just for like during the saving process. There's some like data gets saved, like current level data, global save objects. Like these are the arrays that determine the index for the objects. Then when it's loading, restoring, it keeps certain assets in memory so that it won't like accidentally release them and then like load them again. Other gathered classes that it needs to like when there's like a lot of big list of like actors that it needs to restore, then this makes sure that you can easily access all of the actors that you need to load to the memory before starting spawning actors. Restoration, it starts with, or at least I start with asyncly loading all of the assets and classes, that are referenced by the save game object. You don't necessarily need to do this, but it does help with like hitches and making sure the game runs smoothly. Then handle restore is called on game instance. For originally, I just had like do all of the restoring in one tick and in one big go, which was causing a lot of hitches, and I had to like debug it a little bit. So right now I'm using this restore handler actor, which handles the restoring process over several frames. But because of that reason, it needs to have tick enabled. So you can enable for loading screens when you transition through the levels. You can enable this late place multi-threaded loading screen. That's not like a widget or like a UMG widget um, hard thing, but rather like a slide pasting, but that one has the world rendering disabled, and also any actor cannot tick while that is happening. So I needed to disable that loading screen while this restore handler is doing its thing, because otherwise it cannot tick and do its thing. So I have two different loading screens, one when the actual level is loading, and then when the restoration is happening, I enable a separate loading screen so that the actors can take and do their thing over several frames. Finish loading is called when the restoration is complete and on restore finished. So in game instance, I have this on restore finished delegate, and then I call it when the restoration is complete, and then that triggers a function in the player controller that finishes the initialization of the game. Okay, handle restore. So this is what happens in the game instance, or like the restore actor that handles the restoration. First, I restore all the basic objects, so I think like all the global actors, game instance, player control, player bond, and game state, and custom actor tags. Then I destroy all of the actors that have should delete and restore. So this means that if you place like physics props or something like that on your level that have the iSave interface in them, and the first time you run them, if they don't, of course, delete and respawn anyway because there's no save file yet. But the second time when you come back to that level or load from a save, then they are destroyed. All of the actors in the level are destroyed and respawned by the system. I could do optimization here where if it finds that the actor is in like the same position, like it finds an actor in the same position with the exact same class, then it wouldn't like delete it and respawn it. It would just use that existing actor there. So that would like save a little bit with garbage collection. But I haven't tried doing that. That might also like create new bugs. So it might be a little bit tricky to try to do that just for like just creating problems, new problems with for the sake of optimization. Recreate all objects, so this includes not just actors that need to respawn, For the tagged actors, like the map manager, it will simply find an actor with that same tag. So it will find the map manager for the map. Any other actor, it will respawn there, and dynamic object, it will recreate color restore on actors. So then it restores all the values on the actors. This is important to do for all of the actors only after all of the actors and dynamic objects have been restored. So if actor 2 is referencing actor 1, actor 1 already needs to exist, and if actor 1 references actor 2, then actor 2 already needs to exist and have the correct pointer and stuff like that. Restore dynamic objects, similarly for all the actors. At this point, I call restore custom data on all of those. Then I find like the what. So if I use the front door, then I go through all of the actors that have this eye level change interface actor and call this function level change. No, it's not actually that function. It's called something different. It's called like on level change. I call that function, and with this tag, and if it returns true, then that actor is used as the position we need to spawn into later when the restoration is completely finished. Um, yeah. Call on restore. So at this point, all of the values, including object pointers, should be valid at in all of the actors. So even if actor 1 is referencing actor 2, then that pointer is already valid at this point. The order at which they get called on restore might be a little bit random. So you shouldn't do anything where you kind of assume that actor 1 always gets called before actor 2, except for like global actors. Here you can kind of know that they all get the correct order. But at least they will have like all of the variables restored correctly. But if you do uh, some kind of thing on the restore function, that might you shouldn't assume that they get called in the correct order. Then I clean up some of the pointers and arrays and stuff like that that are only there for the duration of the restoration, and then I call trigger post level change. So I call this function on the selected level change actor if it was a level change. Okay, that's about it. Then just like what this is just like a interface. This is blueprint implementable function, unlike the other one that only can be defined in C++. And has this like this returns true if it's the position where you do need to spawn, and then this is when the actual positioning happens. So for the doors, I just like teleport the player to the position of the door, or just like a small component on the door blueprint that defines where to teleport the player. For the boat system, I teleport the boat into that position and then attach the player to the boat, and then start moving the boat towards the docks. Per actor restoring, so what happens in actor reattach to parent, so transform restore custom data. I have a small demo here. So this is like a super simplified version of the saving system. These two functions, SaveSimpleProperties, only allow saving like few type of properties like assets, booleans, flows. Well, they can kind of save anything. They could save like structs, but because of like object pointers, like referencing other objects. So if I, for example, I had an object pointer here that referenced a completely different actor, then I couldn't save that one because there's no other objects that are being saved here other than this object. So that needs to be like a full save file that is being saved with like actual objects, object indexes into the save. But this function can restore and save like still restore and save like simple properties that are just like anything else than object pointer or a struct with object pointer inside them. And I can show how that works here. So I can randomize these values 4.6. I mean 0.46 and Molotov cocktail, and I can click save data, and then I can randomize this so it's something different, and then I can click and it's 0.46 and Molotov cocktail again here, and randomize again chunk 0.94, save data and load data, and it's the same values again, and these are again just marked with the save game flag here, and that's what makes them save. This save data itself doesn't have the save game flag saved, but that's kind of the logic that it works even in when you're saving the whole game. It goes through all the properties and figures out with how to save them. I use string-based saving. I don't use archive just because I find this one easier to handle with just like especially with object pointers, and it's easier to debug when I need to when I want to look at the save files and see what's going on in them when they are already like text. It's a little bit easier to figure out what's happening in this save file. Okay. Then yeah, this can be called outside, but it only has like a simplified version that doesn't allow saving object pointers to anything else than assets. Single map and array stuff is saved separately, so here it's going through all the properties. If it's an array, it goes to this array map. If it's a map, it goes to this map map. And then if it's like a normal property without any kind of not an array or t-map, then it goes to the singles map with all the data. It looks like this in the actor data, simple actor data, custom save data. I think I might have actor save data, like has this custom save data. Custom save data looks like this with all of the different properties, and then some custom stuff like the class and other stuff like that. Yeah, I have a special handling for structs and pointers. So the pointers is the big reason why the system works like this. And then because structs might have pointers, object pointers in them, they need to be handled in a specific way as well, just in case they have an object pointer. Otherwise, they could be saved just as a string as well, like any other variable. Yeah, pointer saving for non. So I can only save. I do have like this. I might be able to like enable saving arrays even with the simple properties only thing, but so the reason I added this part that doesn't allow simple properties to arrays to save when I have simple properties flag enable is because of the object properties, but I could just check that it's not like an reference to another object, non-asset object there, and enable that for that function as well. But I don't really use it that often. I use it only for like special cases. For normal saving, when you normally save game, it's not a problem because it's not saving them as quote-unquote simple properties. Set relative transfer each saved component, call restore custom data on each saved component. Yeah, so all of the components get their data restored as well. At this point, I have some kind of weird thing in the slideshow where it doesn't want to go to the next slide until I click enough many times. After restoring, so in my game-specific code, I call initialize when the game starts for the first time on all the actors, and then I call initialize even after restoring the actors. On the characters at least, and even on some items. But then they have like on is it they know if it's like restoring the game or not. So in actors, I have a boolean. I could also just set the boolean in the on restored function that determines if it's like first time spawning or like a restoration. So for stuff like randomizing the inventory or abilities, I only do them on the first time setup, and then when they are restored, I don't randomize. I don't call that part of the code anymore. I don't randomize the inventory again. Then when the game is fully initialized, like all of the restore is complete, I set the game, the player controller and the game state and stuff like that as fully initialized, and only then the game logic can start, and like the player turn starts and whatever, and the player can start doing stuff, and I completely disable the loading screen. Yeah, object pointers. So assets, material like meshes, materials, textures, zones, data table, does assets. They can always save normally, no matter what. Global and local separation. So for if you're like referencing an actor that's like a global actor, then it has this like when it saves a string, it will have this like a global exclamation mark global and then some number string, and then if it's local actor, it would have, for example, exclamation mark both hot and then some number as the string that is being saved. Yeah, so the map manager has its saving tag as map manager. I think even find it here. No, that's the global actor. So if I go to the local actors, the both hut, I can see the map manager. It has the map manager actor tag here. And they can be kind of referenced. They are not like recreated. So like I explained a little bit earlier, global is like the type of string that is being saved depending if it's a global actor or local actor, and that is what like is being saved when another actor references this object. Referencing actors in level blueprint. So this is something you need to be kind of aware of. So any actor that returns should be deleted on restore from the interface. They shouldn't be referenced by the level blueprint. You can reference actors like the map manager that have the saving tag and are never destroyed. And this is because, so like, even if you drag and drop the actor reference to the level blueprint, of course, the first time you run that map, it will work normally and find that reference. But then the second time when you have saved the game and restored the game, it will have destroyed that actor, and it will no longer find that actor. and I'm not 100% sure, but it might like keep the hard reference to that object still, and even though it's marked for the destruction, uh, the hard reference will keep that object alive through garbage collection, and the object is never really released from memory. So because of that, it might not be a good idea to use references in the level blueprint for that type of actors that need to be destroyed. Um, Actors that have same intact don't need to be re-added. So yeah, the map manager don't need to be recreated. Um, and only like the map manager and stuff like that should be referenced by the level blueprint. Of course, you can reference any other actor that doesn't do any saving, like the landscape or whatever that doesn't do any kind of saving. You can still reference in the level blueprint. But for anything that you do handle with the saving system, you would need to be careful to not reference. Save header. This I'm actually not sure if there's like a easier solution for this. If there's a way to get like some kind of header data from the save files. So because I haven't like found a way to do this, I have this separate save file that works as like the header file of all the save files, and I save a little bit of data into the header header file about every other save file that I have. So there's a file name, map name, icon, title, description, gameplay tags, and level change tags, and then some other data. And I think by default it only saves the file name and map name, and then everything else needs to be defined by your own game project. I do have the function somewhere here where I do that. So gather save header. So here I'm just getting the current player character. I get the active missions and then get the active mission title and use that as description. And then I use the current character's icon and name as the title and icon. And then the header file, like the header file, I mean the load game menu, like shows those in the screen when I run the game. Yeah, so the game customizes what the header data is. Didn't necessarily need any of this, but like I just wanted to have that data at least there to show like what character you have selected. And when the game is being saved, it can request a screenshot to be saved, which will be saved in like a subfolder of the saved games folder, and that can be later loaded. The screenshot can be loaded with this screenshot loader component, and then when you want to show the save file in the loading screen menu, you can also load the screenshot and show it there. This is like a bit of a problem. So if you copy files to the save games folder, it won't have the header data for that new save game file. Similarly, if you override an existing save game file, the data in the header file won't be up to date. There's not really an easy solution for this because to fix it, you would then need to load each save file by hand and update the header data, and that would kind of and even maybe like run the game sort of, and that would kind of like ruin the whole point of the header file when you would just have like even you would just like load the save file anyway and use a lot of CPU in that sense. Save game instance, I have thought about replacing this with like a subsystem or something like that, so that there wouldn't be like any inheritance problems where you might have like a save game instance, then some other game instance based class that you would want to sandwich between this class and the base game instance class. So just chatting functions that you can use. Start a new game, you select a map you go to and it starts a new game there. Change level, so this is what I use when I go to a door, it triggers that level change, or even in the boat, when the boat reaches the end of the route, it will trigger a level change. Gather header data, yeah, in that base plugin, this is I think just an empty, yeah, this is just an empty function that does nothing. And in my my specific, like game specific project, I have overridden these. Actually, I'm not sure what that. Yeah, I have overridden these two functions to call the game instance. I mean the player controller, and then the player controller like what decides what to do with those that stuff. Get a level that I get global actor tags. Yeah, this is what calls the player controller, and then the player controller calls the party system to receive all the tags for the player characters and the items that the player characters are carrying. Get local actor tags for, I think it finds all the map manager and the stuff like that, and handle restore function. Create save file list. You don't need to necessarily call this yourself, since I have like C++ widget class widget class um, that you can use to like create. Yeah, so here's widget classes that, and these handle creating like the list of save games that you can easily implement with Blueprint, like OMG. Get save files similarly. And then yeah, this is the and I have like some weaknesses that I have in the system. Cannot save animation state. I still think it's maybe better to block saving. I know that some other games have like similar situations where you cannot really save when something is happening. I know in Alien Isolation, when the alien is close to you, you cannot save. I think this is probably more related to game design, so that you don't like save when you're just about to die. But it might also have some kind of technical reasons that when there's some like animation or explosion or whatever going on, it won't save during that, because you might not be able to save any kind of particle effect or anything like that perfectly, especially when a lot of those things are often like run on a thread. Um, should not cannot save widgets, so widgets are meant to be like visual stuff, and you shouldn't even like try to save them necessarily, and the system doesn't really allow for that. I haven't made any efforts to make it work with lever streaming, like I said before. Um, haven't tested it with Lyra or Gas. This might also, like, I don't think it's necessarily that big of a problem to get it work, unless, like, if for example, if in the gameplay ability system component in Gas, all of the stuff that needs to be saved is not flagged with the same K flag, then it's a problem, because then I would have to like manually save them somehow, and know what to know what to save there. So it's really a question. I haven't tested it. I haven't looked at it, so I don't know if they are flagged with the save game flag. Otherwise, if they are not flagged with the save game flag, then you would need to kind of handpick each property and know what to what to save. They are, like I mentioned, it should maybe be a subsystem and not all in the game instance. I cannot save late functions, and same with the gameplay tasks. You can like latent function is just like an object pointer, and the function name and then there's some kind of ID. I don't actually know what the ID. I should read on it. I don't know what the ID does. So it's somewhat easy to like restore in that sense that it's just an object pointer and a function name. But still, there might be some kind of problems if you do try to save those things. And I'm not using farchive. I know, oh, I misspelled archive. Um, um, I have read a lot about archive and how it works, but I haven't tried using that instead of strings. It would of course be a lot of a lot better optimized and take a lot less space. If it was like if each object was saved as binary instead of a string. So that would help with the file size. Currently my file sizes are something like bigger file sizes are something like 5 megabytes, which might be a problem at some point if like the game keeps getting bigger and bigger. So I might want to switch to archives or look at other ways of optimizing. But the fact that they are strings also does make a little easier to like see what's going on in the save file, and also I don't have to like write a specific uh, function for each type of thing. Like I only the biggest thing to worry is object pointers and structs only because of the object pointers. But everything else I can just use this function, and I don't even need to know if this is a float or integer at this point, because I can just export it as a text and get everything I need that way, instead of having to like worry about what type of thing it is. Um, of course, for archive can do that kind of thing, but then the object pointers that need to have the special case is kind of a problem. And I do know that there is like ways to handle that, but just kind of like I started this project as doing this text export thing, and that's why I haven't switched to archive, even though I like realized that I could use archive later. Um, so yeah, that's pretty much the system. I don't know how useful this will be to other people. Maybe like some of the considerations of like how the system works can be like knowing how to optimize it or something like that could be helpful to other people. But and I will try to release this. I don't won't probably won't try to put it on Fab or anything, just because there is already other systems there, and my system is sort of only specific for like turn-based games. Even though I could make it work, but right now, like getting it to work with all of these different cases of like saving during animations would be a lot of work that I don't necessarily want to do when I already have my own project that doesn't need those things. So when like if I needed to do those things, then I would of course do those things. But yeah, that's about it. I rambled a lot. I don't know how understandable any of that was. Thank you for watching.